Welcome to my channel Physics Verse of Shantanu. So today we will discuss A.C. Verma's Concepts of Physics, Chapter 2, that is Physics and Mathematics, which mainly deals with vector, and we will discuss about the solutions of problem number 16, 17, 18, 19, and culminating on problem 20. So let's begin talking about chapter 16. The problem says if A, B, C are mutually perpendicular vectors, show that C cross A cross B is equal to 0, and also we have to tell whether the converse is true or not. Now, given that A, B, and C, these three vectors are mutually perpendicular to each other. Now, A cross B is a vector whose direction is perpendicular to the plane containing A and B, as you can see in this picture. It will be either, if A is in the, let's say, in the x direction, B is in the y direction, then it will be perpendicular to xy plane, that is along z direction, and if otherwise it will be along minus z direction, and not necessarily it will be along these directions, so y and x. It will I mean the theta, that is the angle between A and B, may be anything, and that vector A cross B will be perpendicular to the plane containing A and B, that is this plane. Now C is also perpendicular to both A vector and B vector. Now A vector and B vector both are in the plane containing A and B. Therefore, the angle between C and A cross B is either 0 degree when A cross B is parallel to C, and if A cross B and C are antiparallel, the angle between them will be 180 degree. Therefore, C cross A cross B is equal to 0, hence proved. But the converse is not true. For instance, let's take this example. If A and B are parallel to each other, then also C cross A cross B is equal to 0, because A cross B is equal to 0, since the angle between them is 0 degree, so sine theta will be sine 0, or if antiparallel, it will be sine 180 degree, which will also be 0. So then A cross B is equal to 0, and C cross A cross B also be a null vector. That is, they need not be mutually perpendicular. You can see in this picture. Now, talking about problem number 17, a particle moves on a given straight line. Here the straight line is P prime, or you can say QP prime, with a constant speed v. Now, at a certain time, it is at point P on the straight line path. Now, O is a fixed point. Here it is. O is a fixed point. Now we have to show that OP cross V, that is OP cross V, is independent of the position P. That is, if after some time the particle goes from P to P prime, then new P will be P prime. But OP prime cross V will be equal to, that is OP prime cross V will be equal to OP cross V. That is, it will remain the same. So let's move on to the solution. Here the particle moves on the straight line PV prime, as we have said, at speed V. From figure, we can see OP cross V is equal to OP into V into sine of pi minus theta, because the total angle here is pi, that is 180 degree, and so this angle is pi minus theta, or you can say it is sine theta, because it is OP cross V. Sorry, OP can be shifted here, so this angle is theta, OP cross V, so this is sine theta, not no need to be written as sine pi minus theta, sine theta. into n cap. N cap will be directed inside the paper. There is this, right? So this is OP cross V, OP cross V, right hand rule, right hand thumb rule. So the end cap, the unit vector, perpendicular to OP and perpendicular to the plane of paper, is going inside the paper. So it will be OP into V into sine theta into n cap. Therefore, now what is OP into sine theta? Now, from this triangle, we can say from this triangle we can say that OP. We can say that OQ is equal to OP sine theta, right? So OQ is equal to OP sine theta. So we can write OP sine theta as OQ. So this becomes V into OQ into n cap. Now OQ can also be written as OP prime sine theta prime from this triangle, because OQ is equal to OP prime sine theta prime. Theta prime is this angle. So OP prime sine theta prime, this line is not needed, as I have mistakenly judged it wrong. So it becomes OP prime cross V, right? From here to here, we get OP prime cross V. Therefore, whatever may be the position of the particle, P prime or whatever on the straight line of path, the magnitude and direction of OP cross V remains same. That is, it is independent of the position P, right? Now let's move on to problem number 18. It says the force on a charged particle due to electric and magnetic field given by F is equal to QE plus QV cross B, Lorentz force. Suppose E is along x-axis, Y is along B-axis, B is along y-axis, and we are asked that in what direction and with what minimum speed V should a positively charged particle be sent so that the net force on it is zero. The solution is here. Before moving on to the solution, let's take a mental picture of this thing, that we intuitively can say that V will be perpendicular to the plane containing E and B. There is a xy plane, and further we will show that it will be in the B will be in the yz plane. That is, taking F is equal to QE plus QV cross B is equal to 0, because net force has to be 0 here. Therefore, E plus V cross B is equal to 0. Therefore, E is equal to minus of V cross B. Therefore, the direction of V cross B should be opposite to that of E, right? The negative sign indicates that. Therefore, V should be in the positive yz plane. Again, E is equal to VB sine theta, taking only the magnitude of this, and where theta is the angle between V and B. It need not be B need not be perpendicular to B. Therefore, V is equal to E by B sine theta. Now, in this case, B has to be minimum. Therefore, sine theta has to be maximum, right? Because E and B are have definite values. Therefore, sine theta is equal to 1, which is its maximum value, is equal to sine 90 degree. Therefore, theta is equal to 90 degree. So it must be perpendicular. Therefore, E minimum is equal to E by B. Therefore, the particle must be projected at a minimum speed of E by B along the z axis. In figure, we can see that z axis with theta is equal to 90 degree as shown in figure. Thus, force on it will be 0. Now moving on to question number 19. It says give an example for which A dot B is equal to C dot B, but A is not equal to C. We get the example as shown in, and show it in figure. as shown in figure, A is perpendicular to B, B along west and A is along south, and B is perpendicular to C. Here B is, as you can see, along west, as shown in previous, and but C is along north. So A dot B is equal to AB cos 90 degree is equal to 0, and C dot B is also BC cos 90 degree is equal to 0, since cos 90 degree is equal to 0. Therefore, A dot B is equal to C dot B, but A vector is not equal to C vector. Now there is a last problem, problem number 20. Draw a graph from the following data. You can take a screenshot of this thing, and we have to draw tangents on at x is equal to 2, 4, 6, and 8 of the following of the curve we will have plotted. Find slopes of the tangents and verify the curve drawn in is y is equal to 2x squared, and the slope of tangent is tan theta is equal to dy dx is equal to tan theta is equal to dy dx is equal to 4x. Right. Now let me show you the graph paper plotting. The graph is looking like this. One second, let me show it. The graph is like this. You have to plot it on graph paper using hand, and the scaling is along x-axis. One smallest scale is 0.1 unit, and along y-axis it is 1 unit. Now y at x is equal to 2 is 8, which is 2 into 2 square. Y at x is equal to 4 is 32, that is 2 into 4 square. Y at x is equal to 6 is equal to 72, is equal to 2 into 6 squared, and y at x is equal to 8 is equal to 128 is equal to 2 into 8 squared. So the curve is y is equal to 2x squared, and for slope we have drawn the 4 tangents at 4 points, and for slope we get delta y by delta x at x is equal to 2 is equal to 4 into 2, and delta y by delta x at 4 is almost equal to 4 into 4, and the other approximate values are also at x is equal to 6 is equal to 4 into 6, and x is equal to 3 is equal to 4 into 8. But if it is infinitesimal, delta y by delta x is equal becomes dy dx, which is equal to 4x, and it is in accordance with the data set, because from data set we get it also to be 4x, and here y is equal to 2x squared. Differentiating we get dy dx is equal to 4x. So that the slope is the value of the slope is also verified here. So thank you for watching this.